Okay, 4.6. Limit at infinity and asymptote. Okay. So let me just write down the definition quickly. So limit x approach to positive infinity, the function goes to the L. Also, x approach to negative infinity goes to the also some number L, okay? All right, then if we have the limit x approach to positive infinity or negative infinity, how about, let me denote the plus minus sign in front. So we don't have to rewrite again. So x approach to plus minus infinity. And we said that goes to L, means that some number, right? Then we say the line y equal to L, the number, right? Which is L, is a horizontal asymptote. So basically you did that from pre-calculus, this one. So like this. Let me do this one first, and then I want to do the number first. Okay, where is the number? Evaluate. So we're gonna take the limit in this case. Okay. There's two terms. Then we can say that x approach to positive infinity, 5 minus x approach to positive infinity, 2 over x squared. Okay. Then what do you get this one? We're looking at the 1 over x squared, looks like this, right? Then x approach to positive infinity. What's the graph? What is the y value for this one? Looking at the graph. Okay, you have not done this one long time, maybe that's why. Okay, so let me show you.
Wait, approaching where?
Approach to 0, isn't it?
Yeah, 0.
Okay, approach to 0. How about this one? How can you say that? X approach to positive infinity. What's the limit of 5? Oh, thank you.
Is it just 5?
This is just a 5, right? It's a constant function. It's a 5, right? So we have, well, this is a 0. Okay, so we get 5. All right, good. X approach to positive infinity. What about the inverse of the tangent function? Okay, so this one looks like this. This is pi over 2. This is negative pi over 2. So this is like that. This is like that. Okay. So we're going to positive infinity. So what's the y value? What's the graph behavior?
It's approaching pi over 2.
Excellent. Okay. All right. Sometimes, let me erase this one. Sometimes they don't give us the line, which is a horizontal asymptote. They give us infinity. Or sometimes they give us negative infinity. Okay. So like a polynomial, limit x approach to positive infinity, x to the n, is positive. Also, x approach to negative infinity, x to the n power, when even power. Okay, even power, think about the x squared. Then more steep, right? So when the number is getting bigger, more stiff and more squared in this case, right? Flat. Stiff here and then flat in the bottom, right? Yeah. Better, stiffer. When number is getting bigger. Okay, so then let us check the behavior. Okay, when x approaches to positive infinity, what's the x to the 6th power when x approaches to positive infinity? What's the limit?
Infinity.
Infinity, right? So let me see, evaluate. Let us just do that. About 6 x to the 12. And positive infinity, right? How about if we had an odd number? Okay, odd, think about the x cube, okay? Or straight line is also odd because x to the 1st power. Then when number is getting bigger, more steeper and more flatter on the origin, right? Same as the even power, so steeper, flatter like that, okay? Then if we have 3x to the 13, what's the limit? X approach to negative infinity, what do you get? Okay, when x approaches to negative infinity here, you guys are busy with the drawing. Then what's the graph behavior?
Negative infinity.
Negative infinity, good. Okay, how about this one? Negative 5x to the 7 power. So how do we do this one? We take the limit. What do you want? Positive?
Now it's positive infinity.
It's positive infinity. Okay, wait. If we have, normally we have, look, this is a x to the 7 power, right? Okay, and 5 means a stretch. Now, we have negative sign means reflect above
So it's reflection. So
x-axis, right? So this what the below x-axis one is reflected there, right? It's the same. And then above y, I mean the above x-axis, then like this. Looks ugly, so like that. Can you see that? You guys okay? So then if we're going to positive infinity, then what's the behavior for the graph?
Negative infinity.
Negative infinity, right? Thank you. So we understand? Okay, let me erase this one. What if we have rational function? I'm gonna erase this one. Determine the limits. Is x approach to positive infinity, x approach to negative infinity. All right, so there's a technique. What kind of technique? We take the, we're looking at the highest power. So highest power from the x, which is first degree in this case, right? So what we do, we take the limit, dividing highest power every term. So x approach to positive infinity. Now 3x over x minus 1 over x over 2x over x plus 5 over x. Okay, now we simplify. And then we get 3 over x over and 2 plus 5 over x. Okay, now we're going to determine whether limit goes. Okay, so 1 over x, 1 over x. Like this, right? Oops. Okay. 1 over x. So x approaches to positive infinity. Okay. What's the graph behavior? Approach to where?
Also positive infinity.
Look at the graph. It's 0. Look at the graph. Graph
Yeah.
approaches 0 because there is a horizontal asymptote, right? Okay. Y equal to 0. All right. So then 3 minus 0, 2 plus, same as 5 over x, right? Okay. Then we get 3 over 2. How about negative infinity? Okay, let me just denote the second step. So 3 plus minus 1 over x over 2 plus 5 over x. Okay, then x approach to negative infinity. Then what's the graph behavior? Where to approach? The graph, look.
I think it's also approaching 0.
Yes. So it's also equal to approach to 0, right? Same as this one. So we get 3 over 2. So x approach to positive infinity, negative infinity, we still get the 3 over 2 for this rational function. Okay? How about this one? Let me erase this one. I need a space. Second part, we have 2 over x equal to 3x plus 2x, or x to the third. Okay, now the highest power, which is x cubed, right? So we're gonna divide by every term. Capital limit x approach to positive infinity, and 3x squared, highest one is x cubed over x cubed, or over 4x cubed over x cubed minus the 5x over x cubed plus 7 over x cubed. Okay, now we simplify. Two, right? 2. All right, so then we have 3 there, 2 over x squared over 4 there, 5 over x squared, and plus 7 over x cubed. Okay. All right, so this is the same as earlier, x squared, like this. Okay, even power, 1 over x squared, like that.
Quick question. For the 3x squared divided by x cubed, would it be 3 over x?
Thank you.
You're welcome.
This is the one, huh? Thank you so much. Okay, then what do you get this one? 3 over x when limit approach to 0. I mean the limit of x approach to positive infinity, what do you get? What do you get this one? Looking at this one, when x approach to positive infinity.
Zero.
0. How about second one? 2 over x squared. Over x squared, we're looking at this one.
Also 0.
0 and 4 plus minus 0, 0. Okay, everything is 0. Okay, and we get 0. All right. And also, when x approaches negative infinity as well, we get the same answer. So I want to put the plus minus there. Okay. Rational expression like this, then plus minus, we get the same answer. Okay, C. C part. Maybe we do here. Three x squared plus 4x. And x plus 2. Okay. All right. So before we looking at the highest power, right? But then actually we are looking at the highest power from the denominator. We take the highest power from the denominator earlier, a and b. Okay. But in this case, looking at the denominator, just x, right? Okay, but x is not highest power in the rational expression here, right? Highest power is x squared. Okay, so we're gonna do dividing by x in this case.
Is it always just the highest power in the denominator? That's
From the denominator.
solve it. Okay.
Yeah. Okay. So we get we have 3x squared over x plus 4x over x over x over x over, I mean plus 2 over x, right? Then look, we get 3x plus 4 over 1 plus 2 over x, right? Okay, so what can you see? What can you see the first term?
Would it just be infinity?
Yeah, it's infinity, right? Okay, because other one is 2 over x, we get 0, infinity plus 4, right? Okay, all right. Let me give you a tip. The first one, let me write down A. So A was, oh, wait a minute. It depends on, hold on one second, let me fix this one. We have 3x minus 1 over 2x plus 5. Tip. Take the dominant term. Okay, so in this case, dominant term, which is 3x over 2x, right? Then we simplify, we get 3 over 2. Okay, how about this one? Second one, take the dominant term, which is 3x squared over 4x cubed is the dominant term. Okay. All right. Then this will be what do you get?
3 over 4x.
3 over 4x. Then what do you get this one? The limit?
0.
And we get 0, right? Okay. How about this one? We get 3x squared over x. Then we get 3x, right? So we have a limit. Then what do you get this one?
Infinity.
Infinity, right? Okay. So if we have a rational expression, we take the dominant term. There's a shorter way. All right.
Is the dominant term the highest power from the denominator and the numerator?
Yeah,
Okay.
that's correct. We take the highest, so leading degree, basically, right? From numerator, from denominator. So we take the leading degree. So in this case, it's working only x approach to positive infinity and also x approach to negative infinity. Okay? Is okay? All right, let me erase this one. Okay, let us do 2 more problems. And we are done for today. Okay, so find the limit as x approach to positive infinity and x approach to negative infinity, the rational function like this. Okay, look, when we divide, right, we're looking at the denominator and then take the highest power, right? When we divide, when we simplify, right? Then in this case, the square root of x is the highest one from the denominator. Okay, then we have to know this one. When x is all the positive number, then we get that. Right? From the algebra. Because -2 times -2, which is 4, right? Let me write down. -2 squared, which is 4, which is 2. Same thing. So we have 2 squared equal to square root of 4 equal to 2, right? So radicand. This is -2. This is a positive 2. They're not same. That's why we need to take the absolute value. We want to protect the negative sign, okay? But then when x equal to, let me just stop here, and then negative later on. Okay. All right, so let us do this. Take the limit, x approach to positive infinity. Okay, so we have a 3x minus 2 for x squared plus 5. Then look, (3x minus 2 over), since we have a radical, I want to divide like this. Okay, but then the numerator does not have a radical, so I want to divide it this way. Okay. Then let me rewrite this one. I think x, we have x is x. When x is positive, we have the absolute value of x is negative x when x is negative, right? It's okay? All right, then. I want to rewrite this one this way. (3x over x minus 2 over x over). So we have 4 plus 5x squared. Okay, then we can simplify. 3 minus 2 over x over square root over 4. All right, then when x approaches to positive infinity, what do you get the limit? Limit of 3, what do you get?
3.
3. How about second term? 2 over x?
0.
0 over square root of 4, and then 5 over x squared, what do you get? Limit x approaches to
0.
positive 0. So then we get 3 square root of 4, which is 3 over 2, right? How about when x approaches to negative infinity, 3x minus 2 over square root of 4x squared plus 5. Then let us do same concept. So 3x over absolute value of x minus 2 over over square root 4x squared over x squared plus 5x squared. Now, this time is x approaches to negative infinity, so x is negative number, right? I should erase this. Even. All right, then look, there is the 3x over negative x, because negative number by definition of absolute value minus 2 over negative x over 4 plus 5 over x squared, right? Okay, then look, we get the first term. What do you get? First term?
-3.
Good. Second term, negative is positive, and then we know approach to 0 over square root of 4, and then 5 over x squared. What do you get?
0.
Is 0, right? So we get -3 over square root of 4. So we get -3 over 2. Okay. So this is the final answer. So is this okay? I try to rush again every time.